There are two main forms of cryptography, which are symmetric cryptography and asymmetric cryptography. Symmetric cryptography was created thousands of years ago, while asymmetric cryptography was created in the 1970s. In symmetric cryptography, a single key is used for encryption and decryption, while asymmetric encryption uses separate keys for encryption and decryption. Since symmetric encryption has a single key for both actions, the sender and receiver have to have the same key, because if they don't, the person who receives the ciphertext won't be able to decrypt it to the original plaintext. While in asymmetric encryption, the sender and receiver have their own keys. Because of the simplistic approach, symmetric cryptography is faster to perform than asymmetric cryptography, but since parties have to share keys with each other in symmetric cryptography, key management is difficult, especially because if an unauthorized person obtains a copy of the symmetric key, they will have the access to any ciphertext that was encrypted with it, while on the other hand, asymmetric cryptography is much simpler in regards to key management because each person has their own keys that only they should have access to and aren't shared with others to send and receive encrypted messages. An example of symmetric cryptography is when a user encrypts a file with a password and emails it to someone else. For the recipient to be able to access the file in plain text, they'll have to decrypt it, so the sender will have to contact them and provide them with the password to use. In our asymmetric cryptography example, the idea is the same, but the cryptographic mechanisms are different, as we still have a user sending an encrypted file to another user, but in this example, the sender decides to leverage the public key infrastructure, or PKI for short, to encrypt the file with the recipient's public key. When the recipient receives the file, they are able to decrypt it with their own private key, since asymmetric cryptography is built upon a public key and private key pair, which are mathematically linked to each other. So a cryptographic action with one half of the key pair is validated and processed with the other half of the key pair. Interception attempts where an attacker obtains a copy of the file would be useless to them without the recipient's private key, as any other key would not decrypt the ciphertext to the correct plaintext.